Hi there, my name's Levi and I'm the CEO of Deep Forestry, and we've got these autonomous drones that fly into the forest in between the trees and conduct forest inventory and mapping for carbon credits, ESG, or industrial forestry applications, as well as all sorts of other use cases and verticals where you want to identify objects and conduct measurements. So the drone itself, like I said, is fully autonomous. That means that all you need to do is press one button on the remote control. It will take off and fly through any area, including forests, avoiding everything on its way, and measuring with this LiDAR on the front here. So you can see we've got an Alsta OSO 64 LiDAR, which has 64 channels. It shoots up at 45 degrees and down at 45 degrees, so it can see the top of the trees and the bottom of the trees. Here we have RGB cameras, 2 on the front, and there's 2 on the rear here as well. This drone is 4 kilos, so it's lightweight and easy to use in the forest. And the way that it works is that you take this drone, you basically place it on the ground, and it will survey a local area, about 1 hectare for each area, for each flight. The flights last about 15 minutes or so, and in that time it can measure, 500 to 1,000 trees in that time, depending on the density of your forest. So you're measuring the full stem of every single individual tree, and let me show you what that data looks like. So, as a customer of ours, you'll be flying anywhere in the world, and you take that drone. We can have a look and see how it's being used here. The client has driven down this road and then parked at the end of the road, walked out into the forest with the drone, and conducted individual flights. After 15 minutes, it comes back, they change the battery, then they survey another area, change the battery, survey an area again. You can see that each flight is covering about 1 hectare. Here that looks like 0.8 of a hectare. So about 1 hectare per flight. And then if we look here in the next tab, you can see the details of that particular flight here. So this is all your standard forestry metrics. You can see the number of trees with the dBH, the volume and the height. These are all the standard measurements. But there's actually a lot more going on under the hood here. So you can see here the total number of trees is 389 trees for this particular site. The area, the tree density, the basal density, basal area density, these are all the standard measurements. But if we look under the hood, you can see every individual tree here for a diameter 35 to 40 centimeters. Each single tree has its precise location, georeferenced to about 10 centimeters in the world, and then the diameter, the volume, and the height of each tree. But in fact, there's actually a lot more information in that particular file. So what you see here is every single individual tree and the information on each tree. So this is, again, one flight. And if we look here at an individual tree, you can see that this is one tree. It's about 17 meters tall. And here you can see the tree itself has been cut through east to west or north to south. And you can see the shape of that tree. So if it's got any curves in the tree itself. And then here, the red line is the harvester, and the blue dotted line was our estimate. So we did an estimate, and then the client came on after they'd seen our estimate and checked with the harvester on every individual tree. And you can see here that we're pretty much perfect. The harvester on the red line is bumping up and down the tree, and our line is basically perfect, and you can't tell whether the error is the harvester error or our error. So that means that our errors combined in this research was less than 5%. Of the even like medium-aged trees, so mature trees, it's much less, and that means that we're basically as precise as can be possible in terms of compared to even the harvester outcomes. So you're basically getting to know exactly what every single tree stem looks like using our data. Now, if we look back and we go back into the original area, so as a client, you can export this data as either a GeoJSON or a CSV file. So I'm going to do that right now. You just press the download button, and then I'll export it as a CSV as well. And then if we look at that data, I'll just open it up in the downloads. And what you can do is you can open up Google Earth. So I'll bring that over here. Now, if we look at Google Earth, all we have to do is drag and drop that data into Google Earth. This is what we downloaded off of the website, and you can see every single individual tree here. So I'm just going to pin this to the ground so that it looks correct. And there you can see all of the data on every single individual tree in the forest. And this can be exported into any geoinformatics software. And then you can see here that also the CSV file, this is for import into any type of API or service or cloud system that you're using. So the data itself is available in these types of formats so that you can have success with your forestry. Because we know the entire shape of the stem, we can sort your forests out into different shapes as well. So I'm just going to show you the 3D version of this data. So you've got, and again, this is just 15 minutes of work. You just press one button on the drone and you get all of this information of the forest. So we've got every single individual tree here, and then you can see how the AI has segmented it. And you can see here that the data has all of the information in it from every single tree. And if we look at this kind of data, what we see, I'll just take those numbers away, is that we've also segmented it into different classes of stem and individual tree branches. So woody biomass is very easy to identify. And we can train this AI on different species. So if you want to know which species is which, or if you want to segment your system into different types of forest, then it's really easy. So what we do is we can just run some machine learning algorithms, and every stem will be classified into the type of forest that you're interested in. And we can give that to you in a separate CSV file so that you can sort into, let's say, sawmill wood, pulp wood, or plywood, or different species, and get those species lists and information. And then also we have here a LiDAR, hyperspectral, and RGB sensor fusion. And this is a high-resolution RGB camera. So with this system, you can actually do a lot more very interesting things. You can get a lot larger area per flight, so maybe 50 to 100 hectares per individual flight. You can also use the hyperspectral to identify different types of things in the environment, like photosynthesis, water use, leaf water index. You can also use this camera for identifying nutrients in the environment for agricultural uses. So hyperspectral has a lot of information, and we use sensor fusion between these three sensors and machine learning to identify and measure those things for you in the environment. So my hope is that we can work with you and your team and have a big victory towards taking these amazing autonomous drones into your forests to survey anything that you're looking for, and then work together to add value in your value chain. So thanks for your time. Hi there. This is just a supplemental to add for you to see exactly how our photos actually work on board the drone. So as the drone is flying autonomously through the forest, it's gathering images from every different angle, 4 different cameras. These are 5 megapixel cameras, so they're equivalent to your average family photo. On a regular camera. You can see here the drone is taking off into the forest and flying through the forest here. You can see we've got extremely high resolution for a computer vision platform in real time. So you can see every single individual tree. Again, this is perfectly geo-referenced with all of the LiDAR point clouds, and every single individual tree is marked. So in the photographs, we have connection to each of those trees. With its individual tree number and all of its metadata associated with it. And you can see it's very easy to identify different types of textures, fungus, or anything on the trees, individual leaves of leafy trees, different species on the ground, parts of the system that the ecosystem with dead wood or rotting wood for biodiversity, or perhaps if you're trying to calculate fuel load. Remember, you've got every single image to do 2D machine learning, but you've also got every single part of this forest as a 3D point cloud, and that can be labeled and measured very precisely, centimeter precision on anything. You know, these trees, these little logs on the ground would be easy to identify. You can see dead trees, easy to identify. Any fungus that's on the trees, easy to identify. Even berries on the ground we'll be able to identify. So this can be used for essentially any type of tree species mapping, ground vegetation mapping, fire mapping, anything that you need, fire hazard mapping, and you get a perfect 3D georeference point cloud that can be used then in autonomous robots that might be moving through the forest, or for your field workers, or for other passers-by. Put it online and let anyone else learn about your forests however you think is appropriate.